Hello students. Today let us discuss the topic acceptance sampling. So we have already studied about sampling technique. Now what is acceptance sampling? So to understand what is acceptance sampling, I would like to give you a small example. So let us consider a supermarket which is selling pre-packed sandwiches in its food department. So the sandwiches are brought in batches from a catering firm. Now if the supermarket manager wants to test how the sandwiches are, whether they are fresh and if they are of good quality or not, then what he has to do, he has to unwrap and then taste the sandwich. So after testing it, the sandwiches will not be, it will not be possible to sell them because we have already unwrapped them. So what the manager has to do, so the manager has to make a decision whether or not to select the batch of sandwiches which they are obtaining from the catering firm based on testing a small sample. So one or two sandwiches he may taste and see if they are good, then he may select all the sandwiches. Otherwise, if he finds that they are not of good quality or they are not fresh, then he may reject the full batch. So this is known as this accepting based on the small sample, he is accepting the full batch. So that is known as acceptance sampling. So acceptance sampling can be applied where large quantities of similar items or large batches of material are being bought or being transferred from one part of an organization to another. Okay. So to understand acceptance sampling, let us take an example of a supermarket selling sandwiches in its food department. Sandwiches brought from a catering firm. So if the manager wishes to check for the freshness and quality of the sandwich, he has to unwrap and taste the sandwiches. Based on testing a small batch of sandwiches, he has to decide whether to select or reject the whole batch of sandwiches. So this is known as acceptance sampling. So acceptance sampling can be applied where large quantities of similar items or large batches of material are being bought or they are being transferred from one part of organization to the another part of organization. So acceptance sampling is applied where large quantities of similar items or large batches of material are being transferred from one part of the organization to the other part. So, in statistical process control, we have seen that the purpose of statistical process control is to check production as it proceeds. So, acceptance sampling is applied to large batches of goods which have already been produced. So, statistical process control checks production as it proceeds. But acceptance sampling is applied to large batches of goods which have already been produced. So, the test on the sandwiches is a destructive test because after the test has been carried out, the sandwich is no longer sellable. So, once we have unwrapped the sandwich and we have tasted it, we cannot wrap it and then again sell it. So, it is a destructive test. So, other reasons for applying the acceptance sampling are that when buying large batches of component, it may be too expensive or too time consuming to test them all. So, that is why we will apply acceptance sampling. Acceptance sampling can be applied where there is destructive testing and where there are large batches of components which will take lot of time and money to check them. Then so, in other cases, when dealing with a well established supplier, the customer may be quite confident that the batch will be satisfactory, but will wish to test a small sample to make sure. So, when you are dealing with a very good company, you will already know that the quality of the component which you are taking will be very good, but still you want to cross check to make sure that the quantity is acceptable. Then what we will do, then again we will go for checking a small batch or a small sample. So acceptance sampling can be applied when there is destructive testing involved for testing the component. And when buying large batches of component, as the testing of all the components will be expensive as well as time consuming. And when dealing with well established supplier and we are quite confident about quality of the batch, but still wish to test a small sample to make sure of the quality. Now let us discuss acceptance sampling by attributes. So in acceptance sampling by attributes, each item that is tested is classified as confirming or non-confirming. So actually the items have to be classified as defective or non-defective. But these days we see that no manufacturing firm is ready to admit that they are making defective items. That is why they will stick to the terms like confirming and non-confirming items. So in acceptance sampling by attributes, each item that is tested is classified as confirming or non-confirming. So a sample is taken from a lot and then it is tested. So if it contains too many non-confirming items, the full lot is rejected, otherwise it will be accepted. So same as the sampling technique. So a sample is taken and if it contains too many non-confirming items, the batch is rejected. Otherwise, it is accepted. So for this technique to be effective, the batches containing some non-confirming items must be accepted. If only acceptable percentage of non-confirming items is 0, this can only be achieved by examining every item and removing any which are non-confirming. So this is known as 100% inspection and it is not acceptance sampling. So this method, that is the acceptance sampling method, to be effective, some batches will contain non-confirming items in it. So if you want only acceptable items in your batch, then it can be done by 100% inspection. So each and every item has to be checked. Here in acceptance sampling, we will take a small sample size and we will check. So if the sample size is acceptable, that is it does not have any non-conformities, then we will accept the full batch. But in case of 100% inspection, we will check each and every item. So by acceptance sampling, it is not possible to obtain all the items in the batch which are 100% confirming. So there will be some non-confirming items in this method. So for example, let us consider a jar of jam. So the jar may have to be filled, or it may be of 453 gram and 461 gram. In between these two, it can be filled. So it would be possible to define a jar with contents outside 455, outside the range. That is, if it is 455 and 459, they are. So this method is effective when some batches containing some non-conformities must be accepted. So the The acceptable percentage of non-conforming items cannot be 0 in acceptable, that is acceptance sampling. So the non-conformities or non-conforming items will be 0 only when we examine every item and removing any which are non-conforming. This is possible only by 100% inspection. So let us consider an example of jam jars. So if the contents are required to be between 453 gram and 461 gram. So now here they are saying the jam jars must be of the weight of between 453 gram and 461 gram. What we will do is we will define a jar content outside the range of 455 gram and 459 gram as non-conforming. So what is the firm saying, or what is the quality required is it must be, the jar content must be between 453 gram and 461 gram. So we will assign a range saying if the jar contains are outside the range of 455 and 459, we will say it is non-conforming. So for example, if it is 450, then it is non-conforming. So it is outside the range of these values. So we will make it as non-conforming. So and we will give some acceptance limit also, or we will give an acceptance number also. So we will say that if the batches are containing up to 5% non-conforming items, then we will accept it. So batches containing up to 5% non-conforming items could be accepted. So in this way, we can ensure that virtually all the jars in the batches contains between the 453 and 461 gram. So this is about the acceptance sampling by the attributes. Now the operating characteristic curve or the operating characteristic we have already studied. So we have already studied about the operating characteristic curve. So for a particular plan, the operating characteristic curve is nothing but it is a graph between the percent defective and the probability of acceptance. So provided the sample is small compared to the size of the batch and the sample is random, the probability of each member of the sample being non-conforming may be taken as constant. So this operating characteristic curve, which we have already studied, we know that it is a graph between probability of acceptance and the percent defective. So this graph can be drawn when the sample size is small compared to the lot size and the sample is drawn at random. We can take this probability of each member of the sample being non-conforming as constant. So in this case, that is the all the conditions which I have told you, that is the sample is smaller than the batch and then the sampling is random and each member of the sample being non-conforming can be taken as a constant. In this case, the number of non-conforming items in a batch will follow a binomial distribution. So here the probability, that is the operating characteristic curve, is in this form. So this is the probability of acceptance. This is the percent defective. So and the shape of the graph will be something like this. So here the conditions are: sample is small compared to the batch size. Sample size is small compared to the batch size. Then sampling is random. Then probability of each member of sample being non-conforming may be taken as constant. In this case, the number of non-conforming items in a batch will follow binomial distribution. So here we can see that the shape of the graph is something like this for acceptance sampling by attributes. The next important topic is acceptance sampling by variables. So acceptance sampling can be carried out by measuring a variable rather than classifying an item as conforming or non-conforming. So here in acceptance sampling by variables, we will not classify the items as conforming or non-conforming. So here we will measure the variable instead of classifying it as conforming or non-conforming. So variables like thickness, strength or weight can be measured. So here variables such as, so in this, a typical plan here is to take a sample size of n and we will reject the batch if the mean measurement, that is the x bar value, is less than k. So k is the acceptance number here. So a plan would be to take a sample size small n and reject the batch if the mean measurement, that is x bar, is less than k. So if for example let us take the variable was percentage of impurity in raw material where a small value was desirable. So the plan would be to form the plan would be of the form to take a sample size of n and reject the batch if the mean value, that is x bar, is greater than k. So here this can be changed from greater or lesser than k based on the type of strength or type of variable which we are measuring. So if the variable is percentage of impurity in a raw material where small value is desirable, so percentage of impurity value must be less. So here we can say that sample size n and reject the batch if the mean measurement x bar value is greater than k. So here based on the variable which we are measuring, we have to check the k value. So whether the variable must be greater than or less than k value, and then we will form a plan. So usually it is easier and quicker to classify an item as conforming or non-conforming than to make exact measurement. So this acceptance sampling by variables is a bit time consuming because we have to make exact measurements here. So acceptance sampling by variables is bit more time consuming than acceptance sampling by attributes, because in the acceptance sampling by variables we must make the exact measurements. But the information which are gained from exact measurement is greater, and so small sample sizes are required. So here the information obtained by exact measurement, that is nothing but by acceptance sampling by variable is greater compared to by attributes. So the information which we get from the exact measurement, that is nothing but exact measurement is done by acceptance sampling by variables. So than the information which we obtain from the attributes, more information is obtained by the acceptance sampling by variables. So based on the type of circumstance or type of measurement which we are making, we have to choose either acceptance sampling by attributes or acceptance sampling by variables. So now the operating characteristic curve for the acceptance sampling by variables. So this is all about the acceptance sampling. I hope you have understood the topic. Thank you.